Alright, in this video I'm going to show you another question to do with variable acceleration. This time we are given a piecewise function, so for different values of t we've got different functions for the velocity. So we just need to be careful that whenever we consider a range, we make sure we check what different ranges of t it falls into. So this is just the end part of the question here that I wanted to go through, which is calculating the distance the car travels in the interval between 10 and 20 seconds. Now, before we can do this, we would have needed to work out what this constant value is, which is part of an earlier question. But you can see that since 10 overlaps between both of those, if we just substitute 10 into here, so when t equals 10, v equals 4 times 10 minus 0.2 times 10 squared, and we see that that ends up being 20. Okay, so between 10 and 15, v equals 20. Okay, and we want to work out the distance the car travels between 10 and 20. So we need to see that actually we want to think about this and also this section. So we want to do it in two sections. So let's first of all find the distance for 10 to 15. We have to do it separately because we have to do this one and then we have to do this one. So the distance for 10 to 15 is going to be the integral of velocity with respect to t, okay, because we know that the velocity is the rate of change of displacement, or in this case, because it's going to be positive, it's the same as the distance travelled. And what we need to do is put the limits. So that's going to be between 10 and 15. We're not just trying to find an expression for the distance travelled, we're actually trying to find the distance travelled between these two limits. So this is going to be a definite integral, and we need to put those limits onto our integral. Now, during that time, v is 20. So in this case, we are doing integral of 20 with respect to t between 10 and 15. Okay, and now if I integrate 20 with respect to t, I just get 20t. Because this has sort of got a t to the power of 0 next to it because it doesn't have a t. So to raise that power by 1, I need to create 20t. And we can think about if we were going to go backwards, if we were going to differentiate this, that would go to 20. Now, normally you would put a plus c, but since it's a definite integral, you do not put plus c, you just put your square brackets with your limits. Okay, now we can evaluate that. That is 20 times 15, so we substitute in the upper limit, then we take away 20 times 10, okay, substituting in the lower limit. All right, and that will give us a distance travelled for 10 to 15, which is going to be 100 meters. Okay, so in those between 10 seconds and 15 seconds, it travels 100 meters. Now we need to do the second section. So the distance for between 15 and 20. And now that's going to be this. That's going to be the integral, again with our limits, between 15 and 20 of this function, 8 plus 0.8t dt with respect to t. Okay, so let's integrate that. We get 8t. Then here we're going to need to increase the power by 1, which is going to give us t squared. Then we divide by the new power. 0.8 divided by 2 is 0.4. Again, we don't need a plus c because we are doing a definite integral. So we put our square brackets and we put our limits on. And then we need to work out, okay, we substitute in our upper limit first. Then we substitute in our lower limit and subtract it. Okay, then we can just work that out by putting it in a calculator. And we get 110 meters. So the total distance is going to be the sum of those. 100 plus 110, oops, which is 210 meters. That's the total answer. Okay, it's really important that when you're finding the distance traveled between two values of time, it's a definite integral between those two limits. It's not going to work. What I've seen a lot of people do is trying to work out what's the distance at 10 and then what's the distance at 20 and subtracting them. Because it's all changing, this is a curve. That's not going to work. If we were to draw the velocity, it would be this sort of chunky curve. And remember that the distance travelled is the area underneath that curve. And that's not going to be as simple as the upper value of the displacement take away the lower value of the displacement. Distance travelled is the whole area under the curve, which since it's in these different sections, you need to work it out in these different sections with these two different integrals, because you see you're integrating a different function and you need to put in the limits to find the distance travelled between 10 and 15, which is this, then find the distance travelled between 15 and 20, which is this, then add them up to find the total distance. Okay? Have to do all of that or you're not going to end up with the right answer.